In stats, we looked at one of our last one sample situations, and that is a t-interval. So if we're working with means, numerical data, we need to use the t-distribution and construct a t-interval. And we're doing t, let's write this down, write a better t. Because we are, let's say, are not given, I'm going to pause a second, see if you can fill in the blank, some certain value, the population standard deviation, sigma, which is really confusing because if you look at the first example we have in that paragraph, they give us a standard deviation. But that's the sample standard deviation. That's not the population. So that sentence at the very top is very, very important. When we go to do a confidence interval, it's going to be very similar to a one prop z interval. It's just we're estimating mu, not p. It's got to be a random sample. It's got to be small in regards to the population, which is confusing because we want a large sample. So that's why I typically ignore this step right here. It's not vital for a typical problem. We need a large sample because of the central limit theorem. And if it happens to be small, our second example in this handout is small, you need to look at the graph. And it needs to look somewhat symmetric, no outliers, and you're safe to proceed. There's the formula at the bottom of the screen. And there's going to be a lot of similarity between this and a one prop z interval. So let's dive in. Let's do auto pollution. In this problem, you might hit pause, by the way, and skim through it. In this problem, we are estimating the true mean nitrogen oxides. Emitted by light-duty engines. No hypotheses needed because we are doing a confidence interval. Move on to the plan step, and it looks like it was a random sample. .40 is a nice number because it is larger than 30. Sampling distribution is approximately normal. So I move on to the do step, and I see that they gave us a mean for nitrogen oxide, 1.2675. They give us a standard deviation. Once again, these are two things based on the sample of 40, which means we have degrees of freedom of 39 when we do our t interval. So we jump to the calculator, and it'll do all the work for us. We go menu, stats, confidence intervals, and we want a t-interval. This time we have stats. We don't have a list of data. And our sample mean was 1.2675. whoops, typo there, and 0.3332, sample of 40, and they want a 95%, so I leave that alone. And I'm good to go. Our confidence interval is 116 to 137. And that's about all we need to write down, because we have everything else written down. If you want to write down the margin of error, you can, but you don't have to. That is plenty. So we have 95% confidence that the true mean nitrogen oxide emitted by light-duty engines is within 1.1604 and 1.3741. And that's it for type A, part A. Part B, they ask you to make some more generalizations about this type of engine. So on part B, on the next page, I think it's on the back, and I apologize, I gave you very little room to write, but there's plenty of room to write, because you only need to write one sentence. The EPA has a limit of 1 gram per mile for average nitrogen oxide emissions. Do I think that this type of engine violates the EPA limit? Use your interval. I would lead with what percent of confidence I had, with 95% confidence. Because I'm not absolutely certain. I'm only 95% confidence. We can say this type of engine violates the EPA limit because the entire interval is greater than 1. I don't think saying just 1 is outside of the interval is enough. Because what if the entire interval was less than 1? That would be a good thing. So in this case, I think it's really important to say the interval is greater. Another thing to point out is, what if the interval was, I don't know, let's make up some numbers, 0.8 to 1.3. I still couldn't conclusively say that that engine is in violation, because these are plausible values, and if it's possible that the true mean is lower than 1, or possible that it's greater, I just don't have anything conclusive. What I wrote right there refers to the interval we got, which was 100% greater than 1. Like the entire interval was greater than 1. So that is evidence, significant evidence, that this engine is in violation. We'll work the other problem you see right there tomorrow. Bye.